We want to find the limit for x approaching 9 when we are given this function. The first thing one should always do when one has such a question is to try to do a direct substitution to see whether one will get a finite solution. If you do a direct substitution, I would suggest you first of all substitute whatever the number you have here in the denominator to see whether you will get 0. If you get 0, there's no need for you to continue because you are going to end up with an undefined number. In our case, a direct substitution will yield an undefined result, an undefined number, because the denominator is going to be 0. So the other thing we are going to do is to manipulate the function. One way is, let's represent y by x, the square root of x. So we have y squared is equal to x, and then we shouldn't forget about the limit. X is approaching 9. Since now we are going to use y, and we know that x is equal to y squared, y will be approaching 3 now. So we will write the equation in terms of y. We have the limit of y approaching 3. We have y minus 3 divided by y squared minus 9. Now we go on, we see that the y squared, we have a perfect square here, we have a perfect square here. We can express this into two binomials. So we have the limit y approaching 3, we have y minus 3 divided by y minus 3 times y plus 3. Now we can see that this y minus 3 crosses this y minus 3, so we will be left with the limit of y approaching 3, 1 divided by y plus 3. And now we do a direct substitution, and then we get, when the very moment you do a direct you substitute whatever you have. We substitute 3, we don't need to write the limits anymore. So we have 1 divided by 3 plus 3, and we end up with 1 divided by 6. So 1/6 is what we get if the limits of x approaching 9 and we are given this function. Now if we are given the limits as x approaches 4 and we are given this function, first of all, as I said, the first thing for one to do is to do a direct substitution to see whether if you put it in you will get a finite number. So if we put 4 in the denominator, we see that we get 16 minus 16. That will make this thing here undefined if we should resolve it. So we wouldn't do that. So the direct substitution doesn't work here. We'll be seeing an example where direct substitution works perfectly. But let's think of this now. So since we have this, one thing I will be using, one technique I'll be using is factorizing. You can use that in some or majority of the questions. When you have a question, you have to check some of the things, which technique you would want to use. You can try some others. If it doesn't work, then you try another. So here I would try factorization. So when we have this, we can rewrite it. Well, let's factor them into we can rewrite this as the limit x approaches 4. When we factorize this, we get x minus 4 x plus 1. Basically, if you can remember the if you have a quadratic equation, you can factorize this by finding two numbers that if you multiply, you will get the independent term here, and these same two numbers, if you add them, you get the coefficients of the x term here, and that is minus 4 and 1. That's why I have this here. And now we have this is a perfect square, so we can expand it by having x minus 4 x plus 4. So we already see that we can reduce this if we cancel this and this, so we end up with the limit as x approaches 4, x plus 1 divided by x plus 4. Now we can go on and do our direct substitution. So if x is 4, we have 4 plus 1, we get 5, and then we get 4 plus 4 is 8. So this is the solution for this question here. Now let's look at another question. We have this question where we have the limits of x approaching 0, and we have this function. And first of all, as I always said, we try to see whether if we do a direct substitution we can get a finite number. If we look here, we substitute x is equal to 0 into this function. This thing here, we are going to end up with an undefined result. So what we would do now is we would here I would suggest we find a common denominator, and then we that is manipulate the function by finding a common denominator, and then we will see whether when we afterwards we've simplified a bit whether we can do a direct substitution to find a finite number. So I would find a common. This will be equal to the limit as x approaches 0. Now the common denominator for this part is 2 into brackets x plus 2, and then we see this, we have x we have x plus 2 minus 2. We shouldn't forget all divided by 2x. Now we go on and simplify again. We have the limit x approaching 0. This 2 cancels the zeros, this 2 to give us 0. So we have x now divided by 2 into brackets x plus 2. We see this 2x here is dividing, so if we bring it here we can multiply it by 1 divided by x. Division becomes multiplication when it moves here, so it becomes times. And now we continue the x here. I see that we can cancel x here, Okay, so now we'll be left with the limit as x approaches 0. We have 1 over 2 into brackets x plus 2, and then we have times 1 over 2. So this 2 times 2 is 4. I can go on and do, I think I would want to continue here. We have the limit x approaches 0, 1 over 4, that's coming from 2 times 2 here, into brackets x plus 2. Now we can go on and do a direct substitution. 0 here, so we end up with 1 over 8. So 1/8 is a solution when we have the limit as x approaches 0 and we are given this function. Let's look at another function or another example. Let's see here, if you have this the limit x approaching -2, and then we have this function. The first thing I've always talked about is to try direct substitution. Actually here, direct substitution will solve our solution, because if we plug in the -2 here, we wouldn't get an undefined solution. So we go on and do it. We have the limits as x approach, we are already putting it in, so I don't need the limit. Remember, the very moment you start putting it in, you don't need to write the limits. Now we have -2 plus 3, and then we have cubed, and that gives us 1 cubed, and that is 1. So the solution is 1.